Hey guys, welcome back to my channel. Today we are going to talk about the DNS protocol, also called as Domain Name System in application layer. It is basically used to translate the host name to an IP address. On a web browser, whenever you type google.com or youtube.com or any host name, right, you need to translate that host name to an IP address. Okay, that IP address is basically the web server's IP. So when you want to log on to that particular web page or website, you need to provide the destination IP to the layer 3. So this destination IP we can get from the DNS when you have a host name given and it has to translate to an IP address, and the DNS will return an IP of that particular web server, and that you will use in the L3 header to reach that particular web server. So that's why DNS is important application layer protocol over here. Now it will also do the reverse. If you provide an IP, it will give you an host name. Okay, so DNS is it's the DNS servers basically they have a database which will do a mapping of the host name with the IP address. So you have to fetch that from the database of the DNS server. So let me just quickly show you an example how it will work. Okay, so let's say I have host A over here, right? This is my host A. Now I want to reach a particular website called csc.dtu.in. Okay, now this in is basically we have .com, .org, .edu, .in, country wise also we have, organization wise also we have. So in and there are lots and lots of websites on the internet, probably in millions, right? So in order to quickly fetch these uh, host names and translate them into IP, in order to do it faster, we have divided the database in a hierarchical way. So let's see how it works, right? So first what happens is host A will try to check in its local cache. Okay, it will check in a local cache if it has the IP for that host name. Okay, now it will check in the local cache. If it's there, then it will not have to go to a DNS server to fetch the IP. If it is not there, right? If no, then what happens? It will contact a local DNS resolver, you can say. Okay, this is a DNS resolver. This is generally, this IP address for this is provided by your ISP only. Okay, it's a local DNS resolver on the internet which is much closer to you, and it will check in its cache first if it is there in its cache, right? If it is not there in the cache, then it has to contact a particular name server where it will need to uh, get the IP from. So what this particular DNS resolver will do is, right, it will request. Okay, so DNS has two types of messages. One is DNS query and one is DNS response. So right now what we are doing is querying. We are querying for the DNS translation, for the host name translation, right? So it will, then what it does is it will basically go to a root name server. Okay, let's say this is root name server. So this will basically have the information of which particular server to go to in order to get the information of all the .in IPs. Okay, for .in I'll have a mapping, I'll have an IP address. Then for .com I'll have an IP address. I'll be like, go to this server. For .edu I'll have one. For .org I'll have one. Okay, and so right now I'm looking for csc.dtu.in. Okay, yeah, I'm looking for in, so it will return the IP address of .in. Okay, it will say you have to go to this particular web server. So now what the DNS resolver will do is it will try to reach that particular .in server now. Okay, so this is called as a top level TLD, top level domain. Okay, top level domain TLD server. Okay, so this is basically has all the .in, it will have all the information of .in host names. So what it will do is this will give you the IP of dtu.in. Okay, Now it will have also like maybe say DTU is a university. Let's say DTU is a university, CSE is a subject, and .in is your top level domain. Right? One university, you can have UTT.in, you can have CSU.in. These are different universities, and all of its IPs will be there. So that information will be again be returned to DNS resolver with the IP address. Now DNS resolver will reach that particular IP. Okay, let's say over here I have, now this is nothing but my authoritative name server. Name server NS. Okay. Now let's say I'm requesting for CSE, right? CSE DTU.in. I could have maybe ECE DTU.in over here. It will have, this is basically the database of the server of DTU.in. All the DTU.in information will be inside this particular server. Now this will return the IP of CSE.DTU.in. Okay. Here it goes. Now what DNS resolve will do first, it will cache the particular IP for CSEDTU.in. Okay, and it will also cache, it will basically cache all these values, DTU.ins, CSEDTU.in, and probably .in IP as well, so it does not have to go to that root name server again, right? And then it will return the IP back over here. Okay, let's say the IP is 134.60.30.18. Once the host A receives this particular, it will also cache it in its local cache. Okay, so DNS resolver will cache it, the local cache will also cache it. So next time if it has to reach, it does not have to go even to the DNS resolver. Let's say the local cache gets overwritten because maybe of the size, which would be probably a little smaller compared to the DNS resolver's cache size. So the host A will just have to go to the DNS resolver to get the IP. It does not have to do the entire process again, or going to the root name server, going to the top level domain, going to the authoritative name server. Okay, so this is how DNS works. This is how hierarchical they have made it in order to fetch these particular IPs easily. Okay, now let's talk a little bit about the packet format. Just to see what all contents are there. It will basically run on a UDP protocol. It's like it does not, it's not a time sensitive application. It's a time sensitive application, right? You need to quickly fetch it. You don't care if it's reliable or not. If you lose a packet, it's fine. It's just one packet that is going and coming, right? You can try again in case if you lose it. Okay, so now in the DNS packet format, right? There are certain headers. Let's see. So first we have is an identification. Okay, ID. The host will put in this ID and send it to the server. The server, when replying to it, will again copy this ID to that response packet, and then it will send it back to the host, and the host will just try to cross check and verify that the response is received for that particular request. Then there are some flags. We have some flags over here. This flag will tell you, if it's a request packet, if it's a query packet, or if it's a response packet, and that there'll be many different fields. I'll share a link with you guys. Please go through the packet once. It's not very important to know all of the fields, but just maybe just see it. Then it has the number of questions it asks, right? What is the host name and all of that. Okay, that is a question. And then you have number of answers, ANS, number of answers. Then it will also give you the IP addresses of the authoritative DNS name server, and also if there are additional servers, it will give you additional IPs also. Okay, so you have all the host will have all the information of the top level domain and all of that. Okay, so now in the query message, the answer bits will be set to 0. In the response message, all the answer fields will be set. Okay, and then this will be the general DNS message. It will be a DNS message, whatever information. So whenever you contact the DNS server, it will have a lot of information, not just the IP to host, host to IP mapping or IP to host mapping. It will have, you know, the time to live, uh, what time to live, how long it will live for, and it will have the information of, you know, validity related to domain name, the IP address. It's all stored in the tree-like structure, okay, in the database. So, so this is how the DNS works. Okay, hope that made sense to you guys. If you have any questions, please do let me know. And yeah, do like, share, and subscribe, guys. Thank you.